Hey everyone. In this video today, we're going to have a look at how to sketch cubic functions. Okay, um, and just like quadratics, there's a couple of different possible options that you might be presented with. You might be given something in turning point form, probably not, but you might be lucky, which looks like that, similar to the turning point form of quadratics. It look like that. You might be given one in factorized form. Good luck. I don't think you will get like one. That's nice and simple if you do. But more often than not, you'll be given one in general form, like one down the bottom. And so we'll have a look at sort of the ways you can sort of do each one. So what about if it's in turning point form? What does that mean? Well, what it looks like is you'll get some sort of a graph, and it's going to look like this. Okay. And so just do that again because what happens, what the cubic actually looks like, it actually flattens out and then comes up. I haven't drawn that super well, but you get the idea. So what you're going to have is at this, you're going to have a stationary point here. So where the gradient is equal to 0 and where it's inflecting. You see how it's sort of like, I guess if you're driving a car along this road, then you're turning right. And at some point you stop turning right and start turning left, okay? If you can imagine that, I'll do that again with a highlighter. You're driving your car along here and you're turning right, you're veering to the right. And then at some point you stop steering to the right and you start steering to the left and you start going that way. What we call that in maths, we call that a point of inflection, okay? So I'll just put that, the point of inflection, okay? And it's inflection means that it's the change of gradient is stops going one way, it starts going the other way. And that point of inflection, if you've got turning point form, that is going to be HK. Okay, from the turning point form, you're going to HK. Now, if you get, if A is positive, you'll get what I'll look like there. So on this particular graph, that is, if A is greater than 0, you're going to get this increasing function. It's going to get bigger and bigger. If A is less than 0, then it's going to be, you can probably guess what it is. It sort of comes out and then, oh, that is terrible. Comes in, flattens out and comes out. That's still terrible. I'm going to leave it anyway. So you get some point of inflection there where it stops going one way, starts going the other way. Again, it's going to be HK. And for this one, that's if A is less than 0. So if A is negative, then you get this decreasing function that look like that. Okay, so that's if you've got it in turning point form, it'll look like that. Okay, hope that makes sense. That's a nice and simple one if you get that situation. Second one, if you've got factorized form, then what it will look like is you'll actually get a 0 for x minus p, you get an x for a 0 for x minus q, and you get a 0 for x minus r. In other words, you're going to get something that crosses at p, q, and r. Okay, so they're going to get you're going to get different x-intercepts at p, q, and r. And so what a function will generally look like, it will come up, go down, like that. Okay, so this is if a is greater than 0. Again, it's an increasing function, and you're going to have x-intercepts at p, q, r. So it will look like that. If a is less than 0, so if you've got a negative a, then what you're going to have, if I have I'll try to do it with the same p, q, and r, q, r, you're going to have a decreasing function. So what that means, you're going to come down, up, down like that. So that's if a is less than 0, it's going to be decreasing. So make sure you know the difference between all those. That's how we sort of deal with life if that's in factorized form. What happens if it's in general form like that? Well, there's not a lot we can do except to try to factorize it, because we really need to, you can see here that the most information comes from trying to factorize it either into that factorized form there or into the turning point form there. So we're going to have to do that. In the last video, we saw how we could factorize to get it into factorized form, and that's what we're going to do in this example today, because once we've got it in that form, it's actually pretty easy to sketch. Okay, so let's have a look at this question here. So sketch y equals that. Okay, so firstly, what I'm going to do is I'm going to sort of say that that's equal to px, so some polynomial x, and I'm going to try to throw in some values using the factor theorem, and it's going to be the factors of 2. Here, it's going to be really easy. The numbers I'm going to try are plus or minus 1, and plus or minus 2. All right, so here we go. So let me just try, I'm just trying to find zeros here. So let me try to find P1. That's equal to negative 2 plus 5 minus 1 minus 2. So that's negative 2 plus 5 is 3. 3 minus 1, that, and I've hit it straight off the bat, that's equal to 0. Okay, so what that means that 1 is a 0. In other words, when x equals 1, you're going to get an x-intercept. And what that means is that x minus 1 is a factor. All right, so that was nice and easy. I already hit it on my first one. I could have tried -1 in there if that didn't work, and then I could try positive and -2 if those didn't work. But it needs to be one of them, because remember, because that -2, we're looking for factors of that last constant there. So it has to be either plus or minus 1 or plus or minus 2. But we've hit that there. Very, very good. What we now do is long division. So here we go. So we're going to divide -2x cubed plus 5x squared minus x minus 2. We're going to divide that by x minus 1. And here we go. So what do I need to multiply x to get -2x cubed? I need -2x squared. If I multiply that back down by that, I get -2x cubed plus 2x squared. I will now subtract. Those cancel out. And then 5 take away 2x squared is 3x squared. I'll bring down the negative x here. And then what do I need to times x by to get 3x squared? It'll be positive 3x. 3x times x is 3x squared. 3x times -1 is -3x. I subtract negative x, take away -3x, that's plus, will be plus 2x. Bring down the -2, 2x minus 2. What do I need to multiply x by to get 2x? It'll be positive 2. 2 times x is 2x. 2 times -1 is -2. That's what I like to see. We like to see 0 down there. It means I've done everything correctly, and I am happy as Larry. This is good. Very good. So therefore, why is this not working? Oh, my computer is just freaked out on me. Hang on. Can I get him back? My pen just stopped working. What I'll do is I'll continue this in the next video. Thank you.